Hi folks, Mr. Long here. Today I'm going to work with solving trig equations using the double angle identities. So specifically we're going to start and do the sine double angle, so types of questions you would do that way. So here's the first one, sine of 2x. Just remember that sine of 2x equals 2 sine x cos x, okay? So here's the equation that we're needing to solve right here. And we want all the different angles between 0 and 2 pi that satisfy that equation. What I want you to notice here is that this is 2x and this is x. You can never solve a trig equation unless the angle is the same. In other words, if this one here is 2x, this would also have to be 2x, given this form. Or if this was x, this would also have to be x. They have to have the same angle. So if I look at that, and the first thing I notice is, not the same angle, I must need to use an identity. So how can you get so that they all have just a single x? Well, we remember that sine 2x is worth 2 sine x cos x. Okay, and that's the double angle for sine. So I come down to here, and this is the solution. So in the first line, that's just the original. The second line, I notice that I can represent sine 2x as 2 sine x. So I'm just going to put beside that, I use the identity. And that's to get everything with just a single x in the equation. Well, now I know I can solve it. The next step involves common factoring. So I see that sine x and sine x are common factors. So I common factor out sine x. So now I have that common factor is sine x. We remove that common factor and we solve. So what do we solve? Either sine x equals 0 or this bracket here is 0. 2 cos x minus 1 equals 0. And once I do that, well, obviously sine x is 0. Or cos x is 1/2, right? Cos x is 1/2. So because I have 2 cos x minus 1 equals 0, add 1, divide by 2. So when I do that, when I'm going to do this, when is sine x 0? Well, sine x is 0 here and here, 0, pi, and 2 pi. Cos x is equal to 1/2. Now remember, that's just a simple cos x is 1/2, so that's not a, we don't have to have a u substitution. It's just a regular x value on the unit circle. So, and the x value is 1/2. So when does the x value equal 1/2? Well, from your unit circle, you should know that x1 is up here, that is pi by 3, okay, where the x value is 1/2. So x1 is pi by 3. Then x2 is going to be, this is 2 pi. It's going to be 6 pi by 3 minus pi by 3. Okay, 2 pi minus pi by 3. And that gives us 5 pi by 3. Okay, so here's our solutions. Oh, I made a little boo-boo. Look at this. That was the statement for the domain. It was less than 2 pi, not less than or equal to. So I've got a solution here that does not fit. So my solutions here, 2 pi is not included. Okay, so sine x equals 0. When x is 0 or x is pi by 3, under the same constraint, cos x is 1/2 when x is pi by 3 or 5 pi by 3. Okay, so that's an example of expanding. So this is expanding sine 2x. Okay, so sometimes you'll expand sine 2x. At other times, though, we're going to do a contraction of sine x cos x. Okay, so here's what I notice. In this one, number 2, I have this. So I notice that my equation is 4 sine x cos x equals root 3. And there's my domain for my solution set. And by the way, you may hear other noises. I'm doing this live in the classroom. I'm recording this live in the classroom. So there will be some noise in the environment. For example, I have a very difficult student here. But yeah, not so much. Okay, so here we go. What's the problem here? Well, I've got 2 different trig ratios in the same equation, right? Those are kind of like having different variables, okay? They're kind of like having different variables. So it's kind of like 4ab equals root 3, right? If I have 4ab equals root 3, I've got 2 unknowns in one equation. So I need to represent it with just one trig ratio. How do I do that? Well, I know that 2 sine x cos x equals sine 2x, right? And that reduces from one ratio to one ratio from 2 different ratios. Now, there's different ways to do this. If you've got really good number sense, you're going to do it one way. But what you can do is this. If you see this and you go, okay, I need to get sine x cos x by itself. So the first thing you would do is divide both sides by 4. So you might go sine x cos x equals root 3 over 4. But you know that you need 2 sine x cos x. So now what you do is you multiply both sides by 2. Okay, multiply both sides by 2. Well, that's now going to equal, this is going to divide, the 2 goes into 4 2 times, so it's going to be root 3 over 2, okay? And now I've got 2 sine x cos x is root 3 over 2. But what is 2 sine x cos x worth? Okay, that's the question. What is 2 sine x cos x worth? And now I'm going to go through the solution, okay? So, again, this is a different way to do it. So there's the original equation. Here, we use the identity. So I know that 4 is 2 times 2, and I need 2 sine x cos x. Now I'm left with 2, so I do 2 sine x cos x is now worth this. Now, you notice that every time in the past when we've had an angle that's not equal to just x, we use a u substitution, and I do it again. So here, I used u equals 2x. And then I have sine u is root 3 over 2. And sine u is root 3 over 2. Now I get all my u values, right? And I'm not going to go through that. You know how to do that. So pi by 3, 5 pi by 3. Here's the big idea. I forgot to mention this. I'm working with sine 2x. Okay, I'm working with sine 2x. And the period then is, what's the period going to be for this? The period is going to be 2 pi over k. So 2 pi over 2, which is pi. So since the period is just pi, I'm going to need to have twice as many solutions. So I want you to think of it this way. U is, I'll go over to here, u is actually, x is worth u over 2, right? Because we set u equals 2x. So what it means is I'm going to get, u's going to give me 2 solutions between 0 and 2 pi, but that's going to give me 4 solutions for x, right? Because x is u over 2. So what do? Well, pi by 3 and 5 pi by 3 are the obvious ones. But now what I need to do is add 2 pi to get the next revolution for pi by 3, Here, add 2 pi to get 11 pi over 3, right? Now I have 4 solutions between 0, so 4 solutions between 0 and 4 pi. I have to divide all of those by 2, right? Remember, x equals u over 2, because I have to get all the solutions between 0 and 2 pi. So that means I take the solutions between 0 and 4 pi, and now I divide all of them by 2. Pi by 6 divided by 2, pi by 3 divided by 2 is pi by 6. 5 pi by 3 divided by 2 is 5 pi by 6. 7 pi by 3 divided by 2 is 7 pi by 6. And 11 pi divided by 3 is 11 pi over 6. 4 solutions between 0 and 4 pi become 4 solutions between 0 and 2 pi. Okay, because the period for sine of 2x is just pi. So what it means is, if for example, you're being asked to solve an equation of sine 3x equals, say, 1/2, what you would have to do is you would get all the solutions between 0 and 6 pi, then divide each by 3, right? Well, first of all, you'd set u equal to 3x, sorry. Okay, that's the way it works. And I know that's a little tricky. You may want to rewind this. And another way to show it, I guess, is with the trig function. So if you think about this, right, there's say, sine x. So then sine of 2x is going to go through the cycle twice in the same amount of time. This is sine of 2x. So you're going to get, so here there's 2 solutions, there and there. Here between 0 and 2 pi, if this is 2 pi and this is also 2 pi, you're going to get 4 solutions, okay? 1, 2, 3, 4. Okay. So you have to take u, get solutions between 0 and 4 pi, and divide each of them by 2. Okay, I'm going to stop there. Those are the sine questions. Then what I'll do is I'll do some cos double angle in a minute.